March 31, 1943. The loading dock at Union Carbide's Institute, plant in Kanawha County, West Virginia. A forklift operator named Thomas Hendricks watched the first pallet of Buna-S synthetic rubber roll toward the waiting freight car, and he had no idea he was witnessing a turning point in the war. The material looked unremarkable, dark blocks wrapped in canvas, smelling faintly of petroleum and chemicals, just rubber. Except it wasn't rubber at all, not in the way anyone had understood rubber for the past century. It was something American chemists had conjured from alcohol and petroleum, a substance that 16 months earlier hadn't existed outside laboratory beakers, now being manufactured at industrial scale in a building so new the paint hadn't fully dried on the steel beams. Hendricks signed the manifest. The freight car pulled away, heading east toward tire plants that would transform these blocks into the treads that would carry American trucks from Normandy to Berlin. And somewhere in Germany, intelligence officers were still trying to understand how the Allies were maintaining vehicle production when Japan had cut off 90% of the world's natural rubber supply. They never figured it out. Not until the war ended. German intelligence spent 3 years analyzing Allied logistics, tracking convoy tonnages, estimating vehicle production, trying to calculate when the rubber shortage would cripple Allied operations. They had excellent data on natural rubber stockpiles. They knew about the Brazilian wild rubber program. They understood that British Malaya and the Dutch East Indies, the source of nearly all the world's natural rubber, were now under Japanese control. They ran the mathematics. The Allies should have run out of rubber by mid-1943. Their tank production should have stalled. Their truck factories should have closed. Their aircraft tire manufacturing should have ground to a halt. Instead, American vehicle production accelerated. In 1943 alone, the United States built over 650,000 trucks and military vehicles. The Germans saw the numbers in their intelligence reports and assumed they had to be exaggerated. Propaganda. Impossible. Because according to every calculation, according to basic material science, according to what everyone knew about rubber production, those vehicles couldn't exist. There wasn't enough rubber in the world. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. What German intelligence didn't know was that American chemists had solved a problem that had stumped researchers for decades. That American industry had built an entirely new production infrastructure in less than 2 years, and that by late 1943, synthetic rubber plants were producing material that performed better than natural rubber in many applications. The Germans had their own synthetic rubber program, Buna rubber, developed by I.G. Farben in the 1930s. But German production never exceeded 120,000 tons annually, and that was at peak capacity, with every plant running continuously. American production in 1944 would reach 770,000 tons, from a standing start. In a country that 18 months earlier had been producing less than 4,000 tons annually. This is the story of how American science and industry created something from nothing, how a desperate gamble on unproven technology became one of the war's decisive factors, and how German intelligence completely missed the revolution happening in American chemical plants. It's a story about rubber, but it's really about industrial capacity, scientific innovation under pressure, and the way wars are won not just on battlefields, but in factories and laboratories that the enemy never sees coming. The crisis began on December 7, 1941, though the full implications wouldn't be clear for months. When Japanese bombers struck Pearl Harbor, they initiated a cascade of military operations across the Pacific that would, within weeks, capture the rubber plantations of Southeast Asia. The attack on Pearl Harbor was dramatic, but the conquest of Malaya and the Dutch East Indies was strategic. Japan needed oil from the Indies and rubber from Malaya. The rubber especially. Modern warfare demanded rubber for every vehicle tire, every aircraft tire, every gasket and seal and hose in every engine, every wire insulation jacket, every piece of equipment that moved or flexed or needed waterproofing. The numbers were staggering. A single B-17 bomber required half a ton of rubber. A battleship needed 20 tons. A Sherman tank used rubber in its tracks, its suspension, its engine seals, its periscope mounts. The average military truck contained 50 different rubber components. Without rubber, modern mechanized warfare was impossible. You couldn't move troops, couldn't supply armies, couldn't fly planes or sail ships or operate tanks. Rubber was as essential as steel or oil, and by February 1942, when Singapore fell to Japanese forces, the Allies had lost access to 90% of the world's supply. President Roosevelt understood the implications immediately. On February 15th, the day Singapore surrendered, he held an emergency meeting with the War Production Board. The stockpile situation was grim. The United States had accumulated roughly 600,000 tons of natural rubber before the war, which sounded substantial until you calculated consumption rates. American civilian industry alone had been using 600,000 tons annually before the war. Military needs would triple that figure. At current consumption rates, the stockpile would last perhaps 1 year, maybe 15 months if they implemented severe rationing. After that, the American war machine would begin shutting down for lack of rubber. Bernard Baruch, who had managed industrial mobilization during the First World War, delivered a report in September 1942 that was brutally direct. The rubber situation, he wrote, was the greatest threat to the safety of the nation. Not shipping losses, not manpower, not even oil, rubber. Because without rubber, everything else became irrelevant. You could produce all the tanks and trucks and aircraft in the world, but if you couldn't make tires, you couldn't use any of it. The immediate response was a massive rubber conservation program. Scrap rubber drives became a national obsession. Citizens turned in old tires, rubber boots, garden hoses, anything containing rubber. The government collected 450,000 tons of scrap rubber in the summer of 1942, an impressive figure that represented roughly 7 months of military consumption. Not a solution, just buying time. Tire rationing was implemented. Speed limits were reduced to 35 miles per hour to reduce tire wear. Gasoline rationing followed, not because of gasoline shortages, but to limit driving and preserve tires. The entire civilian transportation system was being constrained by rubber scarcity. But conservation alone wouldn't win a war. The Allies needed production, needed to manufacture rubber in quantities that matched or exceeded consumption. And the only option was synthetic rubber, which in 1941 was barely more than a laboratory curiosity. German chemists had developed Buna rubber in the 1930s, a synthetic material made from petroleum-derived butadiene. It worked, technically, but it was expensive, difficult to produce, and inferior to natural rubber in most applications. American tire companies had tested it and found it unsatisfactory for commercial use. It cracked in cold weather, degraded quickly under stress, didn't grip road surfaces as well as natural rubber. Still, Buna was the starting point, the foundation American chemists would build on. In 1940, anticipating potential rubber shortages, Roosevelt had created the Rubber Reserve Company to stockpile natural rubber and explore synthetic alternatives. The company had contracted with Standard Oil, Goodrich, Goodyear, and other chemical companies to research synthetic rubber production. Progress had been slow. The chemistry was complex, the equipment expensive, the yields low. By December 1941, American companies had produced roughly 8,000 tons of synthetic rubber, mostly for experimental purposes. Then came Pearl Harbor, and suddenly there was no time for careful research and gradual development. The government needed a synthetic rubber industry, needed it immediately, needed it at massive scale. The Rubber Reserve Company began negotiating contracts for production plants before the designs were even finalized. The government would finance construction. The chemical companies would operate the facilities. 15 major plants were planned, each requiring construction of entirely new production lines for chemicals that American industry had never manufactured at scale. The technical challenges were immense. Synthetic rubber production required butadiene, which could be derived from either petroleum or alcohol. The alcohol process was proven, but expensive. The petroleum process was cheaper but more complex, requiring new refining techniques. Then the butadiene had to be copolymerized with styrene to create the actual rubber, a process that demanded precise temperature control, specific catalysts, and equipment that didn't exist in American factories. The engineers were essentially inventing an entire industry while simultaneously building the factories to house it. William Jeffers, president of the Union Pacific Railroad, was appointed rubber director in September 1942, reporting directly to Roosevelt. Jeffers was a blunt man who understood logistics and deadlines. He looked at the construction schedules, looked at the projected shortfalls, and realized the program was in crisis. The petroleum-based plants were months behind schedule, plagued by design problems and material shortages. At current progress rates, synthetic rubber production wouldn't meet minimum military requirements until late 1944. Too late. The stockpile would be exhausted by mid-1943. Jeffers made a crucial decision. He accelerated the alcohol-based plants, which were simpler to build and could be operational sooner, even though alcohol-based production was more expensive and consumed grain that could have fed civilians or military personnel. It was a calculated trade-off, spending more money and resources to get production online faster. The Institute plant in West Virginia, Union Carbide's facility, was prioritized for immediate completion. Construction crews worked around the clock, building while engineers were still finalizing the process specifications. And on March 31, 1943, the first Buna-S rubber left the Institute plant. Thomas Hendricks loaded it onto that freight car without ceremony, without recognition of what the moment meant. The American synthetic rubber industry had just gone operational. The production rate was modest, just a few hundred tons monthly from the Institute plant alone. But other plants were coming online, the petroleum-based facilities beginning production by summer 1943. By December, American synthetic rubber production would reach 17,000 tons monthly. By June 1944, production would exceed natural rubber consumption for the first time. The Germans had no idea this was happening. German intelligence had good information about American natural rubber stockpiles, tracking imports from South America and consumption rates. They knew about the scrap rubber drives, which they interpreted as a sign of desperation. They had detailed reports on tire rationing and speed limits, which confirmed that the Allies were struggling with rubber shortages. All the observable evidence supported the conclusion that the rubber crisis would cripple Allied operations by late 1943. What they couldn't observe were the 15 synthetic rubber plants under construction across the United States. The plants were built in locations like Institute, West Virginia, Port Neches, Texas, and Baytown, Texas, inland facilities far from coastal reconnaissance, camouflaged in industrial landscapes where new construction could be explained as war production expansion without specifying exactly what was being produced. The plants weren't secret, exactly, but neither were they advertised. And German intelligence, focused on tracking natural rubber supplies and Allied shipping, missed the significance of the chemical plants being built in the American interior. The technical achievement was extraordinary. In 24 months, American chemists and engineers had scaled laboratory processes to industrial production, built 15 major plants and dozens of supporting facilities, trained thousands of workers in complex chemical operations, and created an entirely new industry, producing hundreds of thousands of tons annually. The synthetic rubber program employed over 75,000 workers by 1944. It consumed vast quantities of petroleum or grain alcohol, required specialized steel for reactor vessels, needed precise instrumentation that had to be manufactured specifically for this application. And it worked. The rubber produced at Institute and the other plants wasn't identical to natural rubber, but it was close enough. More importantly, for some applications, it was actually superior. Synthetic rubber was more resistant to oil and gasoline than natural rubber, making it better for fuel hoses and engine seals. It could be formulated with specific properties for specific uses, harder compounds for truck tires, softer compounds for aircraft tires, specialized blends for tank treads. Natural rubber was a single material with fixed properties. Synthetic rubber could be engineered. By mid-1943, American tire factories were producing truck tires that were 75% synthetic rubber. By late 1943, the proportion reached 90%, and production kept accelerating. The Germans were still waiting for the Allied rubber crisis to manifest, while American factories were producing more tires in 1943 than they had in 1941, before losing access to Southeast Asian rubber. The impact on vehicle production was dramatic. In 1942, the United States produced roughly 300,000 military trucks and vehicles. German intelligence tracked those numbers and calculated that production would decline in 1943 as rubber shortages constrained manufacturing. Instead, American production in 1943 exceeded 650,000 vehicles, more than double the previous year. And most of those vehicles rolled off assembly lines on tires made from synthetic rubber that German intelligence didn't know existed. The strategic implications were enormous. The entire German assessment of Allied logistical capacity was predicated on natural rubber constraints. German planners assumed that Allied offensive operations would be limited by vehicle availability, that truck shortages would restrict supply operations, that the Allies wouldn't be able to sustain multiple simultaneous campaigns because they simply wouldn't have enough vehicles. Those assumptions shaped German defensive planning through 1943 and into 1944, but the assumptions were wrong. The Allies had enough vehicles, more than enough. American factories were producing trucks faster than the military could distribute them. Synthetic rubber had eliminated the constraint that German planners considered insurmountable. And because German intelligence didn't understand how the constraint had been removed, they continued planning defensive operations based on Allied limitations that no longer existed. This wasn't just about having rubber for tires. The synthetic rubber program had broader implications for American industrial strategy. It demonstrated that American science and industry could solve seemingly impossible problems through massive resource commitment and rapid scaling. The same approach would work for other war production challenges: radar manufacturing, proximity fuses, even the atomic bomb program. The synthetic rubber program established the template: show that with enough funding, enough talent, and enough urgency, American industry could create entirely new technological capabilities in timeframes that seemed impossible. It also revealed something about American industrial culture that the Germans fundamentally misunderstood. German industry was efficient, well organized, excellent at optimizing existing processes. But American industry was more willing to gamble on unproven approaches, to build production facilities before the technology was fully mature, to throw resources at problems and iterate rapidly. The synthetic rubber program was a perfect example. The plants were being built while chemists were still refining the processes. Production began while engineers were still solving technical problems. It was chaotic, expensive, inefficient in many ways. But it worked, and it worked fast. German intelligence officers looking at American industry saw waste, redundancy, what appeared to be organizational confusion. What they missed was that American industry's apparent disorganization was actually flexibility, the ability to adapt quickly, to try multiple approaches simultaneously, to scale successful innovations rapidly while abandoning failures. The synthetic rubber program tried both petroleum-based and alcohol-based production, built plants using different process designs, tested multiple rubber formulations. Some approaches failed, but enough succeeded that production targets were met and exceeded. Major Heinrich Müller of the Abwehr's Industrial Intelligence Section spent months in 1943 trying to reconcile Allied vehicle production figures with rubber availability estimates. His reports show increasing frustration. The numbers didn't match. Allied production should have collapsed by summer 1943, but instead it was accelerating. Müller hypothesized that the Allies must have access to rubber sources his intelligence hadn't identified, perhaps increased production in Brazil, perhaps stockpiles larger than German estimates. He never considered synthetic rubber at scale. German intelligence knew about American synthetic rubber research, but their information suggested it was still experimental, years away from meaningful production. German synthetic rubber production had taken decades to develop, required massive subsidies, and still produced relatively small quantities. The idea that Americans could build an entirely new synthetic rubber industry in 2 years seemed implausible. So Muller and his colleagues looked for natural rubber sources they'd missed, rechecked their shipping data, interrogated captured Allied logistics officers about rubber supplies. They were asking the wrong questions. The rubber wasn't coming from plantations. It was being synthesized in chemical plants across the American interior, in West Virginia and Texas and Louisiana, in facilities that German intelligence had categorized as petroleum refineries or alcohol distilleries, never recognizing them as the foundation of an entirely new rubber industry. The intelligence failure wasn't about missing data. It was about failing to recognize that the technological landscape had shifted, that the constraints of 1941 no longer applied in 1943. And the consequences of that failure were profound. German defensive planning through late 1943 and into 1944 assumed Allied operations would be limited by logistics, by vehicle availability, by the inability to sustain multiple offensives simultaneously. Those assumptions shaped force deployments, defensive preparations, strategic reserves. But the assumptions were wrong because they were based on a rubber shortage that synthetic production had eliminated. When the Allies launched overlapping offensives in Italy, France, and later in Germany itself, German commanders found themselves facing operational tempo they had calculated was impossible. The vehicles that carried those offensives, the trucks that hauled supplies from ports to front lines, the amphibious vehicles that crossed rivers, the aircraft that provided air support, all of them rolled on tires made from synthetic rubber, rubber that hadn't existed 2 years earlier, rubber that German intelligence never knew was being produced. And that intelligence failure, that gap between what German planners thought was possible and what American industry actually achieved, contributed to the strategic miscalculations that left German forces consistently unprepared for the scale and speed of Allied operations in the war's final 2 years. The full scope of American synthetic rubber production became clear to German intelligence only after the war ended. When Allied forces crossed into Germany in 1945, they discovered that German intelligence files contained detailed assessments of natural rubber supplies, projections of Allied vehicle shortages, calculations showing that Allied operations should have been constrained by rubber scarcity through 1944. The assessments were meticulous, based on solid data about natural rubber availability. They were also completely obsolete because they failed to account for the synthetic rubber revolution happening in American chemical plants. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Colonel Friedrich Busch of the Foreign Army's West Intelligence Section was among the first German officers to review captured American documents detailing synthetic rubber production. He sat in a requisitioned office in Bad Nauheim in June 1945, reading production figures that explained so much about why German defensive calculations had proven consistently wrong. The Americans had been producing synthetic rubber at scale since mid-1943. By 1944, production exceeded 700,000 tons annually. The entire foundation of German logistics assessments had been based on a rubber shortage that American chemistry had eliminated. Busch wrote a report for the historical record, analyzing the intelligence failure. German intelligence had focused on observable indicators, natural rubber shipments, stockpile levels, rationing programs. All the visible evidence suggested the Allies were struggling with rubber scarcity. What German intelligence had missed was the invisible revolution, the construction of an entirely new production infrastructure that eliminated the natural rubber constraint. We assumed technological limitations that no longer existed, Busch wrote. We calculated based on traditional production methods, while the Americans were inventing new ones. It was a theme that appeared repeatedly in post-war German assessments. German intelligence had been competent, thorough, careful about verifying information, but they had operated within assumptions about what was technologically possible, and those assumptions had been overtaken by American industrial innovation. The synthetic rubber program wasn't the only example. American shipbuilding had achieved production rates that German planners considered impossible. American aircraft production had exceeded German estimates by factors of 2 or 3. American electronics manufacturing had created radar and communication systems far more advanced than German intelligence had expected. The pattern was consistent. German intelligence would assess American capabilities based on current technology and production methods, and American industry would develop new technologies and methods that rendered the assessments obsolete. The Germans were fighting World War II using World War I assumptions about industrial limits, while the Americans were inventing new ways to transcend those limits entirely. The synthetic rubber program exemplified this pattern perfectly. In 1941, everyone agreed that rubber came from trees, that plantations in Southeast Asia were the only significant source, that losing those plantations would create an insurmountable supply crisis. By 1943, American chemists had made those assumptions irrelevant. Rubber no longer came from trees, it came from petroleum and alcohol. Plantations were no longer necessary. Chemical plants could produce superior materials. The supply crisis had been solved through innovation that German intelligence hadn't anticipated. The human cost of this intelligence failure was significant, though difficult to quantify precisely. German defensive planning in 1944 assumed the Allies would be unable to sustain simultaneous offensives in France, Italy, and Eastern Europe due to vehicle and logistics limitations. Those assumptions led to force distributions and defensive preparations that proved inadequate when the Allies demonstrated logistical capabilities that German planners had calculated were impossible. The result was German forces consistently outnumbered and outmaneuvered, unable to concentrate sufficient strength at decisive points because their planning had been based on Allied limitations that no longer existed. At the Falaise Pocket in August 1944, German forces attempted a fighting withdrawal that depended on Allied supply lines being overstretched, unable to sustain rapid pursuit. But Allied truck columns, rolling on synthetic rubber tires, maintained constant pressure, preventing the organized withdrawal German commanders had planned. Thousands of German soldiers were captured or killed because the expected logistical pause never materialized. During the Battle of the Bulge in December 1944, German planning assumed that even if the initial offensive achieved surprise, Allied response would be delayed by logistics constraints, by the difficulty of moving reinforcements and supplies in winter conditions. But American truck convoys, again on synthetic rubber tires, delivered men and materiel at rates that German intelligence had assessed as impossible for winter operations. The German offensive stalled partly because American logistics proved far more capable than German planning had anticipated. These weren't decisive battles lost solely because of synthetic rubber. Multiple factors determined outcomes. But the consistent pattern of German forces discovering that Allied logistics exceeded German estimates contributed to operational failures across multiple theatres. And that pattern traced back to the intelligence failure regarding synthetic rubber production, the failure to recognize that American industry had eliminated a constraint that German planning treated as fundamental and unchangeable. The broader lesson extended beyond rubber specifically. The synthetic rubber program revealed something about how wars are won in the industrial age. Battles mattered, tactics mattered, courage and leadership mattered, but industrial capacity to solve supply problems mattered more. The side that could identify critical resource constraints and innovate around them possessed an advantage that battlefield brilliance couldn't overcome. Germany had excellent soldiers, skilled commanders, sophisticated tactics. What Germany lacked was the industrial depth to innovate around supply limitations that American industry treated as engineering problems to be solved. Albert Speer, in his post-war memoirs, acknowledged this disparity. He described his growing realization through 1943 and 44 that Germany was fighting a different kind of war than German industry was prepared for. German industry excelled at precision manufacturing, at producing high-quality weapons in limited quantities. American industry excelled at mass production, at scaling solutions rapidly, at treating technological limitations as temporary obstacles rather than fixed constraints. When confronted with the rubber shortage, German industry accepted it as a limitation and adjusted production downward. American industry treated it as a problem to be solved and invented synthetic rubber at industrial scale. The synthetic rubber plants continued operating after the war ended. By 1945, they had produced over 800,000 tons of synthetic rubber. The industry that had been created in desperation became a permanent foundation of American manufacturing. Natural rubber remained important for specific applications, but synthetic rubber had proven its worth. It was cheaper to produce domestically than to import natural rubber from overseas. It could be formulated with specific properties for specific uses. It eliminated dependence on tropical plantations vulnerable to political instability or military conquest. The Institute plant in West Virginia, where Thomas Hendricks had loaded that first pallet onto a freight car in March 1943, continued operating for decades. The plant expanded, modernized, adapted to civilian markets. Workers there produced rubber for automobile tires, for industrial equipment, for thousands of applications that had once depended exclusively on natural rubber from Southeast Asian plantations. The wartime emergency had created an industry that reshaped global manufacturing permanently. German intelligence officers, reviewing this history after the war, recognized how completely they had missed the significance of American synthetic rubber development. Their reports had been accurate about what they measured. Natural rubber supplies were constrained. Allied rationing programs were real. The scrap rubber drives demonstrated genuine concern about shortages. But German intelligence had measured the wrong things, had focused on the rubber supply chain they understood, while missing the entirely new supply chain being created in American chemical plants. It was an intelligence failure, but more fundamentally, it was an imagination failure. German planners couldn't imagine that the Americans would build an entirely new rubber industry in 2 years because German experience suggested such a program would take a decade. They couldn't imagine that synthetic rubber production could scale from laboratory experiments to industrial output faster than natural rubber plantations could be recaptured. They couldn't imagine that American industry would gamble billions of dollars on unproven technology and make it work through sheer resource commitment and willingness to iterate rapidly. So they kept waiting for the Allied vehicle shortage that never came, kept calculating that Allied logistics would collapse under the strain of multiple campaigns, kept planning defensive operations based on Allied limitations that American chemists had already eliminated. And they were consistently surprised when Allied operations exceeded their estimates, when American truck columns kept rolling, when the supplies kept flowing, when the operational tempo never slackened despite distances that should have overstretched supply lines. The rubber crisis that should have crippled Allied operations in 1943 became instead a demonstration of American industrial problem-solving at its most impressive. Faced with a seemingly insurmountable supply shortage, American industry simply invented a new supply source. Faced with complex chemistry and limited time, American engineers built plants while still solving technical problems. Faced with skepticism that synthetic rubber could match natural rubber's performance, American chemists formulated materials that exceeded natural rubber in critical applications. And German intelligence, focused on measuring traditional supply chains and calculating based on historical production rates, missed the revolution entirely. They were still counting rubber trees while American factories were producing rubber from petroleum. They were still tracking plantation output while American chemical plants were synthesizing hundreds of thousands of tons annually. They were still calculating when the Allies would run out of rubber while American trucks were rolling across Europe on synthetic tires that performed better than the natural rubber tires German vehicles used. The 650,000 vehicles produced in 1943 were just the beginning. Production would increase further in 1944, peak in 1945. By war's end, American factories had produced over 2 million military trucks and vehicles. Most of them rolled on synthetic rubber tires. Most of them were produced after German intelligence had calculated that rubber shortages would constrain Allied vehicle production. Most of them contributed to operations that German defensive planning had assessed as impossible given estimated Allied logistics capacity. The synthetic rubber program cost roughly $700 million, a massive investment at the time. But it enabled military production worth tens of billions of dollars. vehicles that couldn't have been built without tires, operations that couldn't have been sustained without trucks, logistics that couldn't have functioned without the mobility that rubber provided. The return on investment was measured not in dollars, but in strategic advantage. The advantage of solving a supply crisis that the enemy assumed was unsolvable, the advantage of operating without constraints that limited enemy planning, the advantage of achieving the impossible because American industry refused to accept that it was impossible. Thomas Hendricks, the forklift operator who loaded that first pallet of synthetic rubber in March 1943, continued working at the Institute plant through the war and for years afterward. He never knew that the material he handled daily represented a technological revolution that German intelligence had missed entirely. He just knew he was loading rubber onto freight cars, doing his job, contributing to the war effort in whatever way he could, which was exactly the point. American war production worked because millions of people like Hendricks did ordinary jobs that collectively achieved extraordinary results. They built the plants, operated the equipment, loaded the freight cars, and never stopped to calculate whether what they were doing was supposed to be impossible. German intelligence officers calculating rubber supplies and vehicle production worked with excellent data and sophisticated analysis. But they were trying to measure a war effort that operated according to different rules than they understood, rules that said technological limitations were temporary, that supply constraints could be innovated around, that what seemed impossible in 1941 might be routine by 1943 if you committed enough resources and talent and determination. The synthetic rubber program embodied those rules perfectly. It took a critical resource that nature provided in limited quantities from specific tropical regions and made it abundant through chemistry and industrial engineering. It transformed a strategic vulnerability into a strategic advantage. It eliminated a constraint that shaped enemy planning while German intelligence was still measuring the constraint that no longer existed. And in doing so, it demonstrated that wars in the industrial age were won not just through military skill, but through industrial innovation, through the willingness and ability to solve problems that less innovative economies treated as insurmountable limitations. That was the lesson German intelligence learned too late, reading captured American documents in the war's final months, understanding finally why their calculations had been consistently wrong. The Allies hadn't just outproduced Germany. They had out-innovated Germany, had refused to accept limitations that German industry considered fundamental, had invented entirely new industrial capabilities, while German intelligence was still measuring the old ones. The synthetic rubber program was one example among many, but it was perhaps the clearest case of American industry solving a problem that conventional wisdom said couldn't be solved, at a scale that conventional estimates said wasn't possible, in a time frame that conventional planning said couldn't be achieved. And, somewhere in the files of German military intelligence, there remained reports from 1943 detailing how Allied vehicle production would decline due to rubber shortages, how logistics constraints would limit Allied operations, how the loss of Southeast Asian plantations would cripple Allied mechanization. The reports were carefully researched, thoroughly documented, logically argued. They were also completely wrong because they measured a war that was no longer being fought, a war where rubber came from trees and supply was fixed and constraints were permanent. The actual war, the war where rubber came from chemical plants and supply, was scalable and constraints could be innovated around. That war wasn't visible in German intelligence reports until it was far too late to matter. Up next, you've got two more standout stories right on your screen. If this one hits the mark, you won't want to pass these up. Just click and check them out. And don't forget to like, subscribe, and turn on the notification bell so you don't miss any upload from us.